So we've done greatest common factor. This is least common multiple. Again, 3 words that tell you what you need. We don't have factor t's because we're going to use m's to help you remember to multiply. So the least common multiple means that you count by this number, you multiply, you say the multiples. So I would say 3, 6, 9, 12, 15. Count by 12s. 12, 24, 36, 48. There's not a point where you stop. Multiples go to infinity. But once you see that you have a number that shows up in both rows, you have found your LCM. So the smallest number that shows up in both of these rows is 12. So 4 and 9. Again, I'm going to count by 4s. 4, 8, 12, 16, 20, 9, 18, 27, 36. If you'll notice, I've counted all the way down. I've done this long line, and I still don't have a shared number, which means that you just keep going. And now you can see I've got a 36 in both rows. So 36 is the least common multiple of 4 and 9. 36 is quite a bit bigger than 4 and 9, but it's still the lowest number that I get when I list the multiples. Let's try some more examples. And there is 30. If you'll notice in these 2 examples, simply multiplying 4 times 9 would have given me 36, and multiplying 5 times 6 would have given me 30. So that's kind of a way that you know when you can stop. If I had to list more than 9 multiples, then something had gone wrong, and I missed one somewhere. But on this one, multiplying 10 and 4 gives me 40. And that is indeed a multiple, but it's not the smallest. If you'll notice, is what I come to before I get to 40 in this row. So sometimes multiplying the numbers will give you the lowest common multiple. Sometimes not. So 20 is the lowest common multiple. 9, 18, 27, 6, 12, 18. And there is 18. Way earlier than 9 times 6, which is 54. So 18 is the least common multiple. So factors, you've got to break it down and the numbers get smaller. Multiples, you're going to multiply and the numbers are going to get larger. So, what if writing the multiples, making those m's isn't your preference? Well, you could do factor trees, especially when you get to the point where you have to find greatest common factors and least common multiples. Doing a factor t and then doing a multiple m is a lot of work. But if you use your factor trees in your Venn diagrams, you can do the work one time and get both answers. Let's take a look at how it works. This does not need a factor tree because it's already prime. So I'm simply going to circle it and do the prime factorization of 12, which ends up with a 2, a 2, and a 3. So if I go to my Venn diagram, like you'll remember, and this one represents 3, and this one represents 12, 3 and 3 are both in both of these factorizations. And this one has a 2 and a 2 left over. So my least common multiple says multiply. You multiply everything in the entire circle. 3 times 2 times 2 is 12. The least common multiple of 3 and 12 is 12. And if you'll remember, the greatest common factor is 3. All right, let's erase these and try 15 and 20. 3 and 5, 4 and 5, 2 and 2. So if my 15 is here and my 20 is here, what I have from the 15 that's in the 20 is the 5. That is going in the middle. But I've got a 3 left over here, and I've got 2 2s left over here. Now, my greatest common factor, if you'll remember, is 5, because that's what's in the middle. But to find the least common multiple, you multiply. 3 times 5 is 15, times 2 is 30, times 2 is 60. So the least common multiple of 15 and 20 is 60. All right, we've already done 20, so I am going to leave that information here, and we'll go ahead and look at what we've got here for 12. So I don't even need to redo the trees. I can just look at what I have here. For 12, I have a 2 and a 2 and a 3. If I list those up here for easy calculations. And then for 20, I have a 2 and a 2 and a 5. So these are going in the middle. And the 3 is here, and the 5 is here. And I am looking for the least common multiple, which means multiply. 3 times 2 is 6, times 5 is 30, times 2 is 60. So the least common multiple of 12 and 20 is 60. And the greatest common factor, remember, is the product of what's in the middle. 2 times 2 is 4. All right, 17 and 8. Now, 17 and 8, I would definitely choose to use these Venn diagrams instead of the M's, because counting by 17s isn't something that comes fairly easy to students. This is a 2 and a 4, which ends up with a 2 and a 2. So for 8, I've got a 2 and a 2 and a 2. And then for 17, it's prime. So if I put these nothing in the center, which means in order to get the least common multiple, I have to multiply 17 times 2 times 2 times 2. The least common multiple of 17 and 8 is 136. 2 things you're remembering. Greatest common factor is going to be a smaller number than I originally started with, but the biggest of the smaller numbers. And least common multiple are going to be larger numbers. So here is another triple diagram that we can check out. We are going to look for the GCF and the LCM of 12 and 20 and 15. So again, we'll start with our trees, which we just did. So I'm just going to write the prime factorization of each of these. And 20 we remembered was 2 times 2 times 5. And 15 we remembered was 3 times 5. So if I identify each of these to be in a circle, this could be 12. So purple is 12, and 20 is red, and 15 is black. So what I see that is going to go in here is what's in every single column. And if you'll notice, I don't have anything in every single column. So let's look at what 12 and 15 share. 12 and 15 share a 3. Okay? And what do 12 and 20 share? 12 and 20 share 2 sets of 4. And 15 shares a 5 with 20. So, the greatest common factor, if there's nothing in the middle, the only thing that they share is 1. The greatest common factor of 15, 12, and 20 is 1. The least common multiple is multiply. 5 times 3 is 15, times 2 is 30, times 2 is 60. So, when your common circle is empty, your greatest common factor is 1. And you might see a chart like this that you would be expected to fill in. You would have to take the information that you have, put it in a Venn diagram, and figure out what you're missing. So let's do Mike's numbers first. Obviously has a first number and a second number. That means we're going to have two circles. His greatest common factor is 5. That is made with a 5 because it's prime. The least common multiple is 20, and one of his numbers is 5. So this is 5, and this is telling me that this whole circle has to equal 5, and I don't know, we're going to call this n, I don't know what this circle is. But I do know that in the whole entire thing, he has to equal 20. Since this is 5, this would have to be 20. So 5 times 2 times 2 is 20, which means that the second number for Mike is 20. Let's use the same thought process and see if we can figure out what's going on with Ethan's numbers. We know the least common multiple is 16. We know that all of these together have to equal 16. That doesn't really help us in the beginning, but this helps us. Our first number is 8, and our second number is 16, which means we have to know the factors of them and where do they go. Well, we remember that 8 is 2 times 2 times 2, and 16 is 2 times 2 times 2 times 2. So that means that 3 of them are going in the middle, and 1 goes here. So let's check to make sure we've got everything correct. The second number is 16. 2 times 2 times 2, that is definitely 16. The first number is 8. 2 times 2 times 2 is 8. So what is the greatest common factor? Well, here it is, 8. All right, let's try Sue's, and then it'll be time to show what you know. Sue has a GCF of 4. Well, there's not going to be a 4 here because only prime numbers go in there, so we're going to put the 2 in the 2. And we're going to know that one of these numbers is 12 and one of these numbers is 20. And if I've got 4 in here, what am I missing on this side to make 12? 2 times 2 is 4, so I need a 3 over here to make 12. If this is 2 times 2, what's missing over here to make 20? Because I've got the 4 times something is 20. I'm missing the 5. And now to find the least common multiple, I have to multiply. 3 times 2 is 6 times 2 is 12, and 12 times 5 is 60. So I have completed my chart by taking what I know about greatest common factor and least common multiple and using them in Venn diagrams. So here's an example of a least common multiple word problem and 2 examples to find the greatest common factor and least common multiple. All right, Teresa is running every 3 days at the park. So she's going to run on the 3rd day and the 6th day and the 9th day and the 12th day. And Violet's going to bike every 5 days. So the 5th day and the 10th day and the 15th day. If they continue this pattern, how many days will pass until they're at the park together? Well, because we know that it's not going to be less than 3 days before Violet sees Teresa, we know we're finding the least common multiple. So for this, I would probably do my the 3 and the 5, and list this. Teresa's going to do 3, 6, 9, 12, and 15, and Violet's going to do 5, 10, and 15. So, on the 15th day, they'd be at the park together. Find the greatest common factor and least common multiple of these 2. So, whichever method you used, you could have done factor t's and then did m's, or you could have just done factor trees for both of them and used a Venn diagram. When you did your 6, you ended up with a 3 and a 2. And when you did your 9, you ended up with a 3 and a 3. So you put them here. What they have in common is the 3. There's a leftover 2 and a leftover 3. The GCF is 3. And the multiple is 18. Okay, let's try 10 and 12. Hopefully with 10 you ended up with a 2 and a 5. And with 12, you ended up with a 2 and a 2 and a 3. Draw another Venn diagram over here. What is going in the middle is the 2. What's left is a 2 and a 3 and a 5. So your greatest common factor is 2, and your multiple is 60.